or there was a. Thank you, and I'm happy to see that there are so many people here, even though it's not the final of the day, but the final of the session. My name is Gustaf, and I am going to be talking about sustainable digital production of wearable, soft-stretchable electronic devices. Let's say that this is not we haven't reached the goal, but this is a goal about reaching the sustainable and digital production. So I'm going to be talking about essentially repositioning a traditional SMT, surface mount technology company into novel application areas. So, and I would like to ask if Erik, if you could, during the presentation, just take a picture of me, because for the European Union, you know how that works. Anyways, so let's see if this goes forward. All right, so Mycronic is a company based in Sweden that makes production tools for the electronics industry for the production of standard PCB solutions. We go from large-scale lithography machines for making structures for the semicon and display industry. We have pick-and-place robots for the placement of components and also testing apparatus for those, and then deposition tools for non-contact and contact deposition of complex fluids, adhesives, solder pastes, etc. And if any of you have never been to a production site for electronics, it looks something like this, where you start with a standard FR4 PCB. You mount it or you load it into a carrier structure. You deposit some kind of material. This is done with screen printing traditionally. We promote dispensing and non-contact dispensing. We go forward to the placement of components, the inspection, which is very important in all electronics, reflow, and then unloading, and then you have to have a whole infrastructure with software and containment of components for these things. So what we're going to be talking about is not yesteryear. When I grew up, electronics looked something like this with through-hole architecture. When you ripped apart your electronics, it looked something like this. They went forward to more effective structures for multi-layer PCBs where everything is surface mounted. The continuation of this is going towards die-based, more advanced packaging solutions. So we're going through more miniaturized. We want more variability in our structure. We want digitalization to be able to handle the information in structure and traceability with the electronics. And also this has to be efficient, because in the end, at least from our perspective is anyways, that our customers are always looking for the return on investment and cost of ownership. But what we identified at Mycronic is that there are a lot of strange things that are happening. So we want to be able to, with existing an array of products, handle novel structures that are non-planar, handle novel materials, and the ability to be able to assemble hybrid structures. And that's where we came into something like this. So this is if you guys afterwards would like to look at these, so this is from a European Union project called Syntec, which is essentially a physiological monitoring device that is based on an ECG structure, but done with liquid metals, which I appreciate the shout out from Eric earlier. But this is done with liquid metal so that you have an extensive stretch structure, but all done with digital techniques and existing production. So these are different cables, connectors, sensor modules, all done digitally within this. And this is an example of the kind of things that we're going to be talking about. Can we do it, and can we do it sustainably? And this is actually works, that it's been done in this project to monitor accelerometer data, ECG, pulse, temperature, etc., in sporting environments in Slovenia, and then with cardiac patients in northern Italy. So coming back to this, so how do we go from this kind of standard rigid SMT world into soft stretchable devices? Well, what we're going to be seeing is that we have deposition of material. We're going to be picking and placing components. We're going to be inspecting things, and then we're going to be getting rid of most of or all of the reflow except for the sensor module. So I'm going to be just outlining these three areas in just quick detail, and if you have any further questions afterwards, then you're welcome to take them. So if we focus on the actual printing, as I said, material deposition is nothing new. So traditional is